Hi, today I am going to discuss the concept of superconductivity. So let's see what it is. Suppose in a lab we are working with certain materials. Suppose this is material A, this is material B, and this is material C. We know all the materials consists of obviously electrons. So this is A and let me name this as insulator. This is B. Let me name this pure metal, and let C be our superconductor. So insulator is named as A, pure metal is B, and superconductor is C. Suppose you take an insulator and just keep the insulator over here. Now decrease the temperature of the insulator. If you decrease the temperature of the insulator, you will see the resistivity of the insulator will also decrease. It will decrease, and when your temperature will be 0 Kelvin, you will get a finite resistivity for the insulators. This is the graph for the insulators. That is A. If you do the same experiment with a metal, that is this one, you will see if you decrease the temperature of a metal and decrease it to 0 Kelvin, the resistivity will also become 0 for the metals. So this is B, pure metal. And here lies the interesting thing. There are some metals. If you decrease the temperature, the resistivity will also decrease. But suddenly, a sharp decrease in resistivity will occur. And that temperature is known as TC. This is critical temperature. I'll explain you this. So, this is the nature of superconductors. If you decrease the temperature, the resistivity of the superconductors C, as I have named this, will decrease, and you will see a sharp decrease in the resistivity. And resistivity is a function of temperature, as you all know this. The temperature at which the resistivity of the superconductors becomes 0 is known as the critical temperature. Precisely to say, the critical temperature is just the critical angle, as you have learned in optics. In optics, if a ray is coming towards this side, if you see this ray is coming towards this side, and the angle of incidence, if it is greater than an angle which is known as the critical angle, there will be a total internal reflection. Not a single wave, not a single ray is going to be refracted. Similarly, if the temperature is below Tc, the object will act like a superconductor, and if the temperature T is greater than Tc, it will come in its normal state. So this is the definition of superconductor. It's a special property of a conductor, precisely to say some of the conductors. It's the temperature at which the resistivity becomes 0, or you may say below this temperature the resistivity actually becomes 0. It's critical temperature. It's just the interface between the two temperatures, normal state and superconducting state. So this is all about superconductor. The property is superconductivity, and the temperature is critical temperature. Thanks for watching the video.